Okay, hello class. Good day. Welcome to our last topic on our dynamics of rigid bodies. We're going to talk about work and energy. So our last topic is about the kinetics of the particle, especially on work and energy. So first, we're going to define what is work and then discuss the work due to a force, due to a variable force, and due to a spring force. So what is a work? So actually, work happens when a force F, let's just say that is F, causes the particle to be displaced. So mo ni siya ang ato ang concept sa work, no. So there is a work if a force that is applied to a particle causes the particle to be displaced. So for instance, if you have a particle over here and then you applied a force F of towards the particle, and then let's say this is our starting position, let's name that S sub 1, and then it moves from here to here on this side. So let's say this is our final position. Then there is a displacement, delta S. So since a particle moved from its first position to another position due to the force, then therefore there is a work done on this particle. So what is the work? So how are we going to get work? So work, at times we use W, but formally we use the symbol U to denote work. So work from the first position, so we use 1 dash 2, that is from the first to the final, or from the initial to its final position. So the total work done on a particle is just the applied force times its displacement. So yung ana na siya. So let's discuss further pag yun. So if we have a particle, let's say we have a particle over here, and then naana siya weight, 'di ba? Let's say it has a weight W. So let's say this is the starting position of the particle, and then it moved from this position here to here, S1 and S2. This is the second position. So we have this movement of the particle. So again, let's say formula na to. So work U is just from first to its final position is just equal to the force times the displacement. So since islant ang iyang movement, let's say we have a angle theta here. So now displacement along the x, let's say this is delta x, and then this is displacement along y, delta y. So ingon siya nga ang work daw kuno from the initial position to its final position is equal to the force times the displacement. So unsa nga displacement atong gamiton, si x or si y? So yung ani mong buhaton, gamiton nimo ang nanatay work, a force which is the weight of the particle, and then what else? Unsa nga displacement, si x ba or si y? So imong buhaton is kung unsay direction ni force, mao pud to nga displacement imong kwaon. Okay? So since ang force is downward or along the vertical, so unsay imong distance sa kwaon? So you should not get the distance along the x. If the force is vertical or going downward, then you are going to use delta y, or the displacement along the vertical component of the particle. So sa unit ani, so actually work has units. It can be positive or negative. So na positive or negative. Positive if force is same direction with motion. So mo gini siya ato gyapon ginagamit, no? And then negative if the force is opposite the motion. So from this example here, ang ato ang work is we obtain a positive work due to the weight of the particle. So what if naay particle here, and let's say it has a force over here. Let's say weight yapon, and then it is denoted by W. And then so this is our starting position, and then this is our final position. So it moved upward. So again, so this is the displacement along Y. This is the displacement along X. And then, of course, this is displacement along its position. Sometimes we use delta S or delta R. So, again, our work from this sample here. So, that is weight times the displacement nga Y. So, is it positive or negative? So, from this sample, ang force is going downward, but the motion along the vertical is going upward. So, is this a positive or a negative work? So again, for the work is positive if the force is same direction with motion, but negative if the force is opposite the direction of the motion. Since ang force is panaog, ang direction is pasaka sa motion, then this is a negative work. So yung ana lang siya ka-simple. Work is just force times distance. So mara ni siya work from the initial to final position is just force times the distance or the displacement. And then, positive siya if force is same direction with the displacement. Negative if the force is opposite with the direction of the displacement or the change in position. Okay. So, next is, sa to natay, due to the work due to a variable force. So di ba at times na amantay ginatagan ta og force. Let's say this is our particle from its initial position, and then we have a force F here, and then ang kani siya nga force F is like a function of the displacement. Let's say F of S. So let's say naka-incline siya. We have theta here. And then this is our final position. Okay. Again, so mo ni siya yung displacement delta S. So this is the displacement along X, and then we have here the displacement along Y. So since this is a variable force, ay mong buhaton is you integrate the displacement. So ang mahitabuan ni ang work from the initial to the final position will look like this man, diba? It is a function of displacement ds. So you integrate it, so you will have a work from the initial to S1 to the final position. So muna siya yung may tabo. Mura na siya ma-integrate nimo ang work from the initial to the final position. Or let's say if imo ni siyang tungaon, actually you can divide the force into components. No, for instance, we also have this situation. If we have a particle over here, this is the first position, and then this is the force. Let's say any force, variable or not, and then we have an angle theta here. And then our final position is over here. This is 2. So there is a displacement along the x component of the particle. We call that delta x. There is also a displacement along the y component of the particle. We call that delta y. Ato po yung direct displacement, which is along the path of its motion. We call that displacement along S or delta R, diba? So what we do is we can also make this, we can solve the work due to the y and due to x. So for the, let's say, x component of the work nga nadan ani, we have the work is the force times the x component of the force, let's say cosine theta, times displacement along x. So let's say ato lang niibutang work 1 and then work 2 is 1 to 2 sub 1 and then 1 to 2 sub 2. So ang next is along y. So we have f sine theta delta y. So maraming siya ganing pon force times distance. So ato lang siya tunga into component. So instead nga pa ng force, kung na at times mas dali siya nga along the y component or the vertical component and then along the horizontal or x component. So depende sa motion sa particle. So this one, unsa man siya, positive or negative? Since ang direction sa x component is towards right and then ang move ang particle from left to right, therefore this is a positive work. And then how about sa y? Since ang force nga y component is downward and then the particle move from this point to this point and then panaog siya along the vertical axis, therefore this is also a positive work. So mo na siya ang work. How about another situation? How about nga if say this is a particle over here, this is our first position, and then we'll have our final position here of the particle. So what if natay force 1 nga nag-act niya, and then napod tay force 2 over here, force 2. So this is we have a angle theta here. So again, imo gyud po ng tagsaon, we have a displacement along x. We also have a displacement along y. So again, work happens if the force applied to a certain object causes the particle or the object to change its position or be displaced. So na-displace siya, na work. So kung yan na galing mahitabo, dili maratol na atay duha ka force ato pa, natay work due to F1, work due to F2. As simple as that. So, ato lang ibutang no nga work due to F1 is just equal to F1 times, since ang work along F1 is downward, and then ang work is dapat i-multiply nimo ang force sa kung unsay direction sa motion. So, ninaog man siya along vertical. So, along vertical po nga displacement imong i-multiply. So, that is delta y. Positive or negative? This is positive since ang force is downward and motion towards y is downward. So this is a positive work. So this is the work due to F1. Now po the work due to F2. So if we know, actually there is F2, if we know the distance of this displacement, pwede na siya diretsyoon nga F2 delta S. But since sometimes it's better to divide them into components, we have then the work of the second force, F2x is equal to F2, then x component. So, pwede ra gyud po nga F2 cosine theta times delta x times ani. So, positive or negative? So, positive because ang x component sa F2 is towards the right. And then, ang motion is towards the right. So, that is positive. Imo lang na i-simplify. We have F2 delta x cosine theta. And then, we have the work along the y. So, F2y. So, same na po F2 sine theta. So, y component of F2 times delta y. Or equal to F2 delta y sine theta. So, ang total work done na to diri for this sample, so this is positive, this is positive. So, total work done na to from the first to second position. So, natay work due to the first or due to force F1 plus work due to force F2 along X plus work due to F2 along Y. Atong i-simplify. Then, we will have kani F1 delta Y plus F2 delta X cosine theta plus F2 delta Y sine theta. So, yan nila siya ka-component. So, kung naidagan force nga nag-act is i-apply na nimo. How about if na ay force or movement nga force which is wala siya motion, like for instance no, in another sample no, let's say we have a particle moving in curve. Okay, pananglitan, this is the particle, di ba? We know that kung ang if this is the particle moving in curve path or in curve motion, na siya tangential acceleration, we have the normal, let's say this is our normal acceleration, then ano siya binormal nga component, right? So unsay path sa motion, so the path of the motion is always tangent to the, I mean the acceleration is always tangent to the path of the motion. How about this acceleration here? So that acceleration is always normal, or it is always 90 degrees to the tangential acceleration. So unsa may buhaton nato ani if this happens? So if this happens and then we have an applied force, let's say our velocity is over there, anong force po nato, let's say paingon pud gyapon didto. So if this happens, ang ato alang buhaton atong i-consider is ang kung ano ang direction ni force. So kung sa po to ang direction ni motion. So ang direction ni motion is along this path. So kuani mo og component ni force nga along this path. Okay, so this is in curvilinear motion. So that's also to summarize, work is just the, actually work happens if there is a force and then there is a displacement. Ana ra. So ang symbol sa work is U. So this denotes work. So the SI unit of the work, unsa SI unit sa work, so this since ang work nato is, di ba, force times distance or displacement. And then we atong unit for the force is Newton. And then unit nato for displacement is meters. So Newton times meter in work, that is joules. Joules or joule. So symbol is 1J. So ang unit of work nato which is let's say 1 Newton meter, that is just equal to 1 joule or 1J. Ganun na siya. So if there is a particle and then daghan force niya na ay F1, na ay F2 pag diri, and then there is an F3 over there. So ang mao ra gyud pud mo buhaton kung ani mo work due to F1, work to F2, yes F1, so pa Y F2, and then work due to F3 X or Y. So imong i-break into components. And then positive if force is same direction with motion, di ba? And then negative if force is opposite, no? So see here we have the same direction of the force. And then if the force is opposite, then ang sign convention ni work is negative. So ana lang. Okay? So that is the work of a particle.